Good morning, students. Today we will talk about the range of trigonometric functions. We all know that there are 6 trigonometric functions, that is sine, cos, tan, sec, cot and cosec. Today we will see how to find the range of these trigonometric functions. Now see here, in case of an unit circle, we have already discussed in our earlier videos that in case of an unit circle, cos theta is nothing but your x and sin theta is nothing but your y. And since the circle I have considered here the unit circle, so the value of x lies between -1 and +1. It can be equal to 1, it may be equal to -1. Similarly also, the value of y is also lies between -1 and +1, and the value of y may be equal to +1, also it may be equal to -1. So in place of x we can write here cos theta. So we have seen that our cos theta lies between -1 and +1, and sin theta is also lies between -1 and +1. Now if we apply the definition of modulus, from here we can say that mod of cos theta is less than is equal to 1 and mod of sin theta is also less than is equal to 1. So that the value of cos theta and sin theta lies between -1 and +1, and it may be equal to 1 and also -1. Therefore the range of cos theta and sin theta is the closed interval -1 and +1. Now since mod of cos theta is less than is equal to 1, therefore we can say that mod of sec theta is greater than is equal to 1. Also mod of cosec theta is greater than equal to 1. And by the definition of mod x, we know that mod x is nothing but your plus x, and another value of mod x is nothing but your minus x. So mod of sec theta we can write, in place of mod sec theta we can write here minus sec theta as well as plus sec theta. If we write here minus sec theta, then we will get minus sec theta is greater than is equal to 1 and plus sec theta is greater than is equal to 1. Now from this line we can say that sec theta is less than is equal to -1 and sec theta is greater than equal to -1. Similarly, we can find the ranges of cosec theta also. Therefore, the same range of sec theta and cosec theta is nothing but here r minus open interval -1 and +1. That is, the value of sec theta and cosec theta cannot lies in between -1 and +1. Now, if cos theta is equal to x and sin theta is equal to y, then our tan theta is nothing but your y by x and cot theta is nothing but your x by y. Now you see here, the value of tan theta tends to plus infinity or minus infinity whenever x tends to 0 and y and x are of the same sign. If they are of same sign, it will be plus infinity. If they are of different sign, it will come out as minus infinity. Therefore, the range of tan theta is nothing but your open interval minus infinity to plus infinity. Also, the range of cot theta is also minus infinity to plus infinity. Next one is our basic identities. Basic identities. There are, you have already got it in your HSLC course that in trigonometry there are 3 basic identities. That is your cos square theta plus sin square theta equal to 1. Sec square theta minus tan square theta equal to 1 and cosec square theta minus cot square theta equal to 1. Now in case of an unit circle, if we consider any point Pxy on the circumference of the circle and Pm perpendicular on x-axis, we can say that Ym is nothing but your x and Pm is nothing but your y. And since OPM is a right angle triangle, therefore we can write Om square plus Pm square is equal to your OP square. OP is nothing but your 1. So m square plus pm square is equal to 1. Therefore, we can write x square plus y square is equal to 1. In place of x, we can write here cos square theta. In place of y, we can write sin square theta. So cos square theta plus sin square theta comes out as 1. So this is the basic identity of this trigonometry chapter. Now, if cos theta is non-zero, we can divide these whole identities by cos square theta. If we divide it by cos square theta, we will get, and after simplification we will get sec square theta minus tan square theta equal to 1 And if sin theta is not equal to 0, we can divide these whole identities by sin square theta, and after simplification we will get cosec square theta minus cot square theta is equal to 1. So if we know the value of any one function, that is if we know the value of sin theta, we can find the value of cos theta, and whenever we know the value of cos theta, we can find the sec theta, and by knowing sec theta we can find the value of tan theta, and also when sin theta is known to us we can find the value of cosec theta, and with the help of these third identities we can find the value of cot theta. That is, if one trigonometric function is known to us, we can find the other values. Now I am considering here one example. This is a very important example. This is cos theta equal to x plus 1 by x possible for x belongs to R. That is, if x is a real number, can we write cos theta equal to x plus 1 by x? Now, if we write cos theta equal to x plus 1 by x, then after simplification we will get x square minus x cos theta plus 1 is equal to 0. This is a quadratic equation, so we can find the value of x. X is nothing but here minus b plus minus root over b square minus 4ac by twice a. So it will comes out as cos theta plus minus root over cos square theta minus 4 by 2. Since x is a real number, therefore the term inside the square root should be of positive sign. Therefore cos square theta minus 4 is greater than is equal to 0. From here we can write cos square theta is greater than equal to 4, and after simplification we can say that cos theta is less than is equal to minus 2, or cos theta is greater than equal to minus 2. But we know that the value of cos theta lies between minus 1 and plus 1. So it cannot be less than equal to minus 2. Also it cannot be greater than is equal to 2. Therefore cos theta equal to x plus 1 by x is not possible. Similarly, sin theta is equal to x plus 1 by x is not possible for any real value of x. This is your homework. I hope you can do it. Now our third part is of this chapter is special angles. So I am considering here the angle pi by 4. Now if we consider a unit circle, and let us consider pxy be any point on the circumference of the unit circle whose center is at O, such that angle AOP is nothing but your pi by 4. Right? Therefore, if xy be the coordinate of p, then x is nothing but your cos of pi by 4, y is nothing but your sine of pi by 4. If we consider another point Q on the circumference such that it is the image of p with respect to x-axis, right? Therefore, we can write here, that is, the point p and q are equidistant from the x-axis. Therefore, the coordinate of q will be nothing but your x, minus y. So from here we can say that our chord PQ is nothing but your y plus y is twice y. And since angle AOP is pi by 4, angle AOQ is also pi by 4. Because if we consider these two triangles, a right angle triangle, that is, if we let PQ cuts the x-axis at a point, suppose M, so therefore we can write POM and QOM are congruent. So the angle AOQ is nothing but your pi by 4, and AOP is also pi by 4. Therefore angle POQ is nothing but your pi by 2. Also angle AOB is nothing but your pi by 2. Therefore, we can write our angle arc AP is pi by 2, also arc AQ is pi by 2. Therefore, since arcs are equal, therefore chord PQ is also equal to your chord AB. And the length of chord PQ is nothing but your twice y, therefore the length of chord AB is nothing but your twice y. Now from the triangle AOB, we can use the Pythagoras theorem here, that is your OS square plus OB square equal to AB square. That is your 1 plus 1 is equal to 2y whole square. That is 4y square equal to 2. On simplification we will get y is equal to 1 by root 2. Since it's xy is a point on the first quadrant, pxy is a point on the first quadrant, therefore I am considering here only the positive value of y. Similarly, from the relation x square plus y square equal to 1, since it is a unit circle and xy is a point on the circumference of the circle, so from this relation we can find the value of x. Because y is known to us, the value of x also comes out as 1 by root 2. Therefore, cos of pi by 4 is 1 by root 2 and sin of pi by 4 also comes out as 1 by root 2. Since cos and sin are known to us, so we can find the value of tan pi by 4, cot pi by 4, cosec pi by 4 and sec pi by 4. Let us consider another example of some special angle. Now I am considering the second example is pi by 3. In the similar way, if we consider any point pxy on the circumference of the unit circle such that angle AOP is nothing but your pi by 3. So we can write cos of pi by 3 is nothing but your x and sin of pi by 3 is nothing but your y. If we consider q minus x, if we consider another point q on the circumference of the circle such that image of p is nothing but your q with respect to y-axis, right? Since q is the image of p with respect to y-axis, therefore the distance of the point p and q are equidistant from the y-axis. Let pq cuts y-axis at the point c. So from here we can write cp is nothing but your cq. Now if we consider that these two triangles POC and QOC, from these two triangles OP and OQ are equal because the radius of the circle. Therefore we can write here angle OPQ is equal to nothing but your OPQ is nothing but your OQP, and the line PQ and x-axis are parallel to each other and OP is the transversal. Therefore angle AOP is nothing but your OPQ, that is angle OPQ is pi by 3. Since angle OPQ is pi by 3, therefore angle OQP is also pi by 3. Since the two angles of a triangle are pi by 3, therefore automatically the third angle will be also equal to pi by 3. That is, all angles are pi by 3 means 60 degree. All angles are 60 degree. Therefore we can say that triangle OPQ is an what type of triangle? It is an equilateral triangle. Since it is an equilateral triangle, therefore all sides are equal. That is, OP equal to OQ equal to PQ. OP, the length of OP is 1, OQ is 1, therefore the length of PQ is nothing but your 1. Now you see here, since CP is nothing but your x and QC is nothing but your it is also x. Therefore PQ is nothing but your twice x. So twice x is nothing but your 1. Therefore x comes out as 1 by 2. Therefore CP is nothing but your CP is nothing but your 1 by 2. Now from the triangle OCP, this is a what type of triangle? This is a right angle triangle. So we can write OP square equal to OC square plus CP square. So from here we can find the value of y, and the value of y comes out as root 3 by 2. So cos of pi by 3 is nothing but your half, cos 60 degree equal to half, and sin of pi by 3 is nothing but your root 3 by 2. That is sin 60 degree equal to root 3 by 2. So these two angles are known to us. So these two functions are known to us, sin and cos. We can find the other trigonometric ratios. That is tan pi by 3, cot pi by 3, sec pi by 3 and cosec pi by 3. I hope it's clear to you. So it is your homework. Try to find the value of angle pi by 6. It is cos pi by 6, sin pi by 6. I hope you can do it. That's all for today. Thank you everybody.